Okay, Project Goodwood camera cars for Honda. 1/10 scale we're going with. There's my original car that I did some testing with outdoors, make sure it worked. The camera. I've used a high performance camera, that's why it's quite big, a Sony 800 line to get a good picture. There's the transmitter there with better quality aerial on it now, and but that's not the car I'm going with. So after looking around for a 10th scale car, I've come up with this HPI one, shaft drive. I'm actually going to run it in front wheel drive so that people can't go mad with it. It's got to be driven by normal public people, not experienced racers. It's quite a fit though, 1/10 scale, to get all the electronics in it, because there's an awful lot to fit in this car. I put a clear body shell on it at the moment, which is approximately the size of the Honda shell that's going to go on it, the new concept car NSX for 2015. I've got an NSX on there at the moment, the old one, but it's basically to get the roof height for the camera. So when the body's moulded up, the camera will actually be able to look out the screen, won't be too low if they get the roof and the screen all in the wrong place. So I put the clear body on so I can get everything in the right place, and the camera will be looking out through the windscreen. Now let's just take the body shell off, so you can see. Now the camera is mounted on the servo. Luckily with this car I can cut the top deck, which is metal, and drop the servo into it, and then when it's glued in position, everything could also be moved backwards and forwards slightly before it's glued in position, so get the ideal camera position. The camera is actually mounted on a little swivel at the moment, so it can be positioned properly if the servo is not quite centered. There's a lot of electronics to go in here. You've got the camera and the transmitter will work off 12 volts, unfortunately, so I need a 12 volt, got up scale the voltage from 7.4 volt to 12 volts, so I've got a little 12 volt voltage multiplier there. Because it's got to be driven from a special steering wheel system which is going to be made, I've had to change the radio. Going to go with a Futaba 2.4 gigahertz, got an aircraft transmitter, which will be used just for the modulation transmission, and they're using the body connection in the back. This socket in the back down here will be connected to the custom made wheel system, so that's why I've got to use this type of transmitter, and therefore the receiver will be changed under that switch there. I'm going to put in the matching Futaba receiver. It's got a switch. This car comes with a brushless motor, a brushless speed control which does forward and reverse. I've geared it right down, the smallest pinion I can get, put in it to slow it down so people can't go too fast. It's still pretty fast, probably does 15 miles an hour, which is easily fast enough for what they want. It's under that cover, the pinion. The motor is hasn't got any timing on it, which still goes fast, can't slow it down really. There is some power settings on the speedo, but at the moment everything's looking good. Bundled up the wires there. Receiver. Now there's steering, because the custom wheel will not be able to set the endpoints on the steering. I'm going to have to fit this nice little interface to the steering servo, which can set the endpoints left and right. You can also set the neutral and reverse the servo if necessary. It's a nice little piece of electronics, so that's got to be wired in. All the wires have got to be shortened. There's a little voltmeter here which will show the voltage of the LiPo, the main LiPo, at all times, so that the mechanic who's going to switch the car on can see whether the battery's going flat. Normally, of course, it will start off around over 8 volts when it's fully charged, and you can run it down. When it starts getting to about 7 volts, you're going to have to take it off and get it recharged, as we don't know how long the cars are going to run, with the public driving them quite slowly and stopping and starting. So that voltage display will help the mechanic to tell if the battery's going flat. There is a voltage cutoff when it goes totally flat in the speedo, but we don't want that to happen halfway through when someone's driving it. The transmitter here in this bit of heat shrink, and this nice high gain aerial I've put on it to increase the transmission performance. I hope to be able to get that under the body. It's got a bendy coaxial which should be able to bend it down. I've also put a microphone in. You can just see the mic poking out here. I've wired that into this transmitter. It doesn't come with a mic or anything, but I've wired it. It's a little amplified mic. You can't just put a normal one in, so I've wired that in. Powered it up with also 12 volts, and it's works pretty well. Unfortunately, I'm not sure where to place it at the moment. It can be heat shrink nicely in there, but it's a bit near the fan. If I'm going to fix this to the top deck, I don't know if that fan is going to make a whirring sound. The reason I put a mic in is not just for background noise, it's so that the mechanic can speak close to the car, and it'll come out on the person driving the car. Their monitor will have speakers, so he can tell them to stop pressing the accelerator or messing around, so while he's trying to get the car in position. So that mic, I've got to test that it picks up the voice. Okay, I might have to move the position of the mic. Hopefully not, because I want everything neatly taped and shrunk and wrapped and fixed, so nothing can fall out if the cars get abused or knocked about. I don't want anything falling out or wires being pulled off or anything, so everything's going to be tied down and fixed in place nicely. So I've got to get all that electronics. The battery is going to be a LiPo. At the moment I'm testing it just with a standard NiCad. That's going to go. I'll probably use these foolproof connectors. They're quite ugly and big, but they are foolproof. You don't want any mistakes of anyone plugging it in back to front when they're in a rush. And I'm going to I've got wires for the servo on that the camera's mounted on, because the camera turns it turns left and right with the steering, so looking out the window. Got to wire all that in. I'm going to try and shorten the cables as best I can. The car drives pretty well. It's very heavy. It's about 2 kilograms when it's all loaded up, but it goes okay. I've driven it outside, and it handles and turns quite nicely. Just in front wheel drive. I just took the rear drive shafts out to turn it to front wheel drive, so if we wanted forward drive, we could put it back in again. The surface that the car will be driven on is going to be some sort of rubberized safety flooring that they use in exhibitions. Seems pretty grippy actually. It's nice and black, and I think it'll work very well, and especially if they paint some lines on it and make it look like a real road. So these aerials, there's 2 aerials. Being an aircraft receiver, got 2 aerials down here. They'll be fixed out the way, one vertical and one along the side somewhere. so that should be fine. A couple of other things I'm going to fix. I've got to put an LED in somewhere in front of the camera low down to tell the people then it's powered up. I haven't got that LED yet, but it'd be a little light. The reason why is that there'd be two stages. I'm going to plug it in, the camera and transmission to come on, so it shows up on the monitor where the person's sitting, so we can see that the car is getting ready. The sound also, so you can speak to the person and tell them to stop turning the wheel or stamping on the accelerator. And then when they're not messing around, then I can throw the switch on and turn the speedo on, which will also bring up a light, a LED in front of the camera, which will light up showing that the power's on and not to press the accelerator, but it's all ready to go. So I'll do that as well, and hopefully it will work. Now I've got to make 8 of these. They'll be in 2 sets of 4, so they'll all be on matched. All the frequencies all have to be sorted out and everything. But that, I'll tell you how that gets on after I finish building one of these and testing it. And there's also the the wheel and monitor, which someone's going to sit out to drive this thing. That's going to be all sorted out. I'll show you that as I do it. Anyway, I'll press on with this.